Hi, my name is Dr. YakovSynder. Really enjoy teaching here at OCA. I teach mathematics. The main thing for me is that students understand why the math works the way it does, and I go to a lot of effort in class to get them to figure that out by themselves as much as possible. So I will scaffold them and I will help them and I'll give them hints, but I will also challenge them a lot to figure out why the math works by themselves as much as possible. I find that when they do that, they not only enjoy it a lot more, but they understand it much better, and their mastery of it is much greater because they can have confidence in it when they figure it out. Now, not necessarily as individuals, sometimes it's often as a group, bouncing ideas off each other, we come to consensus, but the idea is that they become convinced of the math that we're learning. So one example of what I'm talking about would be reducing fractions. So for example, if you have the fraction 4 over 2, as most of you probably remember, it reduces to 2. And the way that we do that is we divide the top by 2 and the bottom by 2, and then we get 2 over 1, which is 2. So when I teach this, the key idea is, why are you allowed to make this move? Why are you allowed to divide the numerator, the top, and the denominator, the bottom of a fraction by the same number? You get what seems like a new number, but in reality it's the same number as the original number. Why is that the case? So what I do in class is I'll elicit what is this 2 over 2 in the middle, and 2 over 2 just means 2 divided by 2, and any number divided by itself is 1. So when we divide the top by the same number as the bottom, we're dividing this number by 1. Dividing a number by 1 changes the form of the number, but it doesn't change the value. The actual number is the same. So I would get them to come up with that themselves, give them a few hints, and then also do a lot of reiteration throughout the year, because this is a very important concept in dealing with numbers and solid number sense. So I'd make sure that we revisit it a lot. It also holds for multiplying the top and bottom by the same number. It also comes up in algebra, comes up in a lot of math, and it's a very important principle that you're just multiplying or dividing a number by 1, which is not changing it. So that's an example of what I'm talking about. It's like I'm holding Clorox and olives container, but I also really enjoy challenging students with what I call challenge problems. So a challenge problem is a problem that gets them to think outside the box. So this is a very simple one, but it's a classic question of why manhole covers are round. So manhole covers are those heavy metal covers on the streets that cover up tunnels that go down into the plumbing and et cetera, and the cables down there, and they're round. And it's a fun problem. It involves geometry. The basic reason is, if you look, a round cover turned on its side, the diameter stays the same and it will not fall into the hole in the ground. It'll be stable. Whereas if you had a cover, for example, that's square, the diagonal is actually longer than the sides. You can work out exactly how much longer in geometry, but what that means practically is, even though the top seems stable now, if you were to turn it and rotate it, it could fall into the hole. And obviously it wouldn't be safe. So that's an example of geometry applied to real life. I have a lot of challenge problems like that I enjoy giving the kids throughout the year. Some of them are easier, more basic. Some of them are very difficult. The main goal is just to get them to think outside the box, to realize the importance of thinking creatively. And thinking outside the box is really critical in math and in science and in any field. Another example of getting kids to think is, when I teach them math, I try to bring in the real world as much as possible. So a lot of children have trouble dealing with negative numbers, for example. So let's say you have 5 plus -7 as an arithmetic problem. So something like that, I try to come up with a good real world example. So there are many. One of my favorites is a Tug of War. So you can think of the addition of a positive and a negative number as a sports game where two sides are tugging. One is tugging in a negative direction, the other tugging in a positive direction. So they're working against each other. And what happens in a tug of war is most of the force cancels out. That's why the rope moves very slowly in either direction usually, because the two sides are canceling each other out. So you can use this to teach about arithmetic and negative and positive numbers. If you have two positive numbers adding, it's as if both sides were pulling the same way to the right, if you have two negative numbers being added, it's as if both sides were pulling the same way to the left. So then you would add the forces. You would add the forces together, just like you would see in Tug of War. But if they're pulling in opposite directions, the signs are different, they're mostly going to cancel out. So then you actually have to subtract the absolute values. So you have to look at the difference between 7 and 5, which is 2, and ask yourself the question of which side's going to win. And for that, the number with the bigger absolute value is going to win. So this -7 is going to beat the -5, so you're going to be left with -2, or a small win pulling to the negative side. So that's an example of using the real world to help them get concepts.